Students, today we are going to discuss about the electrostatics. This topic is very useful for the 10th class as well as the 12th class students. Here we know that the electrostatics, static means rest or electro means charge. Branch of physics deals with the study of electric charges in rest. Now, what is the electric charges and how they develop, how they produce? Now, if the charges in rest, then there is the electricity known as the static electricity. Static electricity is due to the electric charges in rest. Such type of electricity develop due to the friction of the two objects. As we see that we are already familiar that if glass rod rubbed with the silk cloth or a plastic comb moved in the dry hair, then it has tendency to attract the light particle towards it. Here, before rubbing, there was no any attraction. After rubbing, this glass rod acquires the tendency to attract the light particle towards itself. Such type of phenomenon called the electrification. Inside, electrification is a property developed in the glass rod by virtue of which it attracts the light particle towards itself. Now, question arises: how the electrification takes place? The electrification is due to the production of electric charges in the rod after the rubbing. Here, our responsibility to discuss detailed idea about the electric charges. Now, this frictional electricity, why it is called the static? Because the electric charges developed in the body not moved in the other part of the body. Those charges are rest in the rubbed part. So it is called the static electricity, frictional electricity or the static electricity. Now we have to discuss what is the electric charges. Electric charges. If question arises, what is the electric charges? Some students give the answer that the transfer of electron is called the electric charge. No, it is not the electric charge. It is the process of the production of electric charges on the body. It is known as the conduction process. Now, what is the electric charges? Suppose there are two objects, A and B. If A consider electron, B is also considered the electron. The mass of electron is m, and the mass of this electron is also m. These two electrons are separated by a finite distance. Then there are two types of the forces between them. The force between these masses known as the gravitational force, and the force between two electrons known as the electrostatic force. Now, before rubbing, of any two objects, there is only the gravitational force. Because charges was not produced in the body. The, those bodies are not able to attract each other with the light particle. Now, after rubbing, there is the attractive property, force of attraction, called the electrostatic force. Certainly, there is the hidden property in both objects, which came in the light after the rubbing and is responsible for the electrostatic force. That property is called the electric charge. How will you define the electric charge? What is definition? The property of elementary particle of matter. Property of elementary particle of matter responsible for the electrostatic force. This property is the intrinsic property. So we can write here the intrinsic property of elementary particle of a matter responsible for the electrostatic force between any two objects. Is called the electric charges. As we know that the electric charges, when these charges are in rest, there is the static electricity. When these charges will be in motion, there will be the current electricity. If current passing through any conductor, it will produce the magnetic field. So, electric charges play this very important role in the electrostatics as well as the magnetism. So, what is our responsibility? Our responsibility is to find out the detailed idea about the electric charges. The basic idea about the electric charges. We know that after rubbing, the glass rod acquired the charge. With the help of the GLE, gold leaf electroscope, we can detect as well as find out the nature of the charge. And after detection, it was clear that there are two types of charges, positive and negative. Now, here plus plus, minus minus. Like charges repel to each other. This was also confirmed by a general activity. Rub a glass rod with the silk. Hang this rod freely. Again, rub another glass rod with the silk. Carry second rod near to the first. It will repel. There was the like charge in both the rods because both rods rubbed with the silk. So like charges repel to each other. Similarly, embark, it is the special type of the material. Rubbed with the kite skin funnel, then it also having attractive property. One amber rod hang freely, carry another amber rod near to the first, it also repel. But if the first rod rubbed with the silk of glass, carried near to the amber, it is attracted. Certainly, there are different type of charges on the glass rod as well as on the amber. So, like charges having the repulsive property, unlike charges attractive property. This phenomenon is called the fundamental law of electrostatics. What is the fundamental? This law, according to this law, like charges repel to each other and unlike charges attract to each other. Now, third property is the conservative property. Before running, both the materials were the electrically neutral because no one having the tendency to attract the like particle. So before rubbing, total charge on the body was zero. After rubbing, if it acquires one positive, it will acquire the one negative. So total charge is also one positive, one negative, zero. As total electric charges before rubbing is equal to total electric charges after rubbing. It also can be stated electric charges neither created nor destroyed but transferred from one body to another. You are familiar that if any body loses the charge, it acquires the positive charge. If any body gaining the charge, acquires the negative charge. So it is the transfer of electron from the one body to another. Next point is the electric charges having the additive property. Additive. If there are the different types of charges, the total charge is the sum. It is the sum. Algebraic sum of the individual charges. For example, 2 Coulomb plus 2 Coulomb is equal to 4 Coulomb. 2 Coulomb plus 3 Coulomb is equal to 5 Coulomb. But minus 2 Coulomb plus 3 Coulomb, it is equal to the only 1 Coulomb. It has the additive property. And the last property, which is very important, known as the quantization of charge. Here, if electric charges transfer from one body to another, then body will acquire the charge. The total charge on the body is the total charge. Total charge on the body is the integral multiple. It is the integer. Integer. It is the integral multiple of the elementary charge E. So quantization of electric charge is stated in the form that total charge on a body is the integral multiple of elementary charge E. That is Q is equal to plus minus N. On the basis of the quantization of charge, here I have given to the numerical problem questions. Find number of electrons in 1 Coulomb charge. Here Q is 1 Coulomb, E is 1.6 10 power minus 19 Coulomb. Of N, we have to find out. Q is equal to NE, here is equal to QI, 1.1.6 to the power minus 19, which is equal to 6.25 to the power 18. That is, this number, the number of electrons 6.25 to the power 18 will constitute 1 Coulomb charge. Now, what is the unit and dimension of electric charge? Electric charges are the stable constant. Unit, SI unit is Coulomb in honor of the scientist, and CGS unit. It divided into two categories, ESU and EMU. Electrostatic unit and the electromagnetic unit. That is stat Coulomb and the AB Coulomb is the absolute Coulomb. AB means absolute Coulomb. Now, question arises, why we select CGS unit in ESU and EMU? Since the electric charges play the role in the electricity as well as the magnetism. When we are going to study the electric charges in electrostatic electricity, the CGS unit is in ESU. When we are going to study the electric charges in magnetism, CGS unit is EMU. Now, what is the relation between ESU and EMU? 1 Coulomb is equal to 3 into 10 raised power 9 ESU, that is state Coulomb. And 1 Coulomb is equal to 1 upon 10 EMU, that is EV Coulomb. We can establish the relation between EMU and ESU. 1 upon 10 EMU is equal to 3 into 10 power 9 ESU. So EMU upon ESU is equal to 3 into 10 power 10. And then the speed of light in CGS, it is C. Speed of light. The ratio of EMU and ESU, it is a very large quantity. So EMU is much more greater than the ESU. What is the use of EMU? We know that F is equal to QBV sin theta. Is the force on the charged particle moving in the magnetic field. So B is equal to F upon QB. If force is in Newton, charge in Coulomb, speed in meter per second, then unit is 1 Tesla. It is SI unit of magnetic field. We have to convert this Tesla into CGS. So 1 Tesla is equal to 10 raised power 5 dyne. It is in the magnetic field B. So it is 1 upon 10 AB Coulomb. Centimeter per second. 10 power 2 centimeter a second. 10 consider it will be converted into dyne AB Coulomb, that is ESU. Centimeter per second. It is the 4 gas. It is CGS unit. Here this unit plays the important role. Thus are about the electric charging. Thank you.